This is demo lecture to find the motional EMF. First of all, we should know what is motional EMF. Whenever a conductor is moving in a magnetic field and magnetic field and velocity are perpendicular to each other, then there is an induced EMF across the conductor. This is called motional EMF. This EMF is due to motion of the conductor, therefore called motional EMF. So let's derive the expression for the motional EMF. Let us consider a rod of length L which is moving in a magnetic field. The velocity, magnetic field and length are orthogonal to each other. Let us consider the rod is moving along the x-axis and magnetic field is acting in y direction and conductor is along the z-axis. So when conductor is moving in the field, the force on positive charge present inside the conductor is given as F is equal to Q V vector cross B. So F Q V cap cross B J cap. This means force is Q B K cap. The force on positive charge is Q B B. This force is acting along the z direction, that is towards the point A. The same force feels the negative charge inside the conductor and the direction of force is towards the B, that is towards minus k direction, negative z direction. So since these two charges are feeling some force, so positive charge moves towards A and negative charge moves towards point B. Since these two charges are getting separated, there is a potential difference between the points A and B. Let us consider this is the potential difference. Since there is a potential difference between A and B and there is a distance between A and B, so the electric field between points A and B is given by V by L, that is potential difference divided by distance between the points. Since this is the electric field between the points A and B, so the charges now in the conductor feel an electrostatic force which is QA, that is V into Q divided by L. This is the electrostatic force. And this force is in opposite direction to the magnetic force. So the electric force and magnetic force now balance each other. So let's balance the electric and magnetic force equal to FB. VQ by L is equal to QV. So cancel out the Q and separate the V. So this becomes V L V. So the potential developed across the terminals of the conductor, that is the end point of the conductor, is given as V potential is equal to BLV, that is magnetic field multiply with length multiply with velocity. This is the motional EMF. Same expression can be derived with another method. Let's see that method also. Here is a rail of conductor, and this is the another conductor kept over this. This is making a loop, so flux passing through the loop is phi is equal to magnetic field multiply area. The area of the loop is x multiplied. So the overall flux becomes d into x into. Now since the conductor is moving towards right side, so given as b into t. So total flux becomes b l b into t. This is the total magnetic flux crossing the area of the loop any time. Now the magnitude of induced EMF is equal to magnitude of rate of change of magnetic flux with respect to time. That is d by dt of B L V B L V dt by dt. So the induced EMF is B L V. The magnitude of the induced EMF is magnetic field multiply length of the conductor and multiply velocity of the conductor. So here we are only taking the magnitude of the induced EMF, not the direction. So this is induced EMF for conductor moving magnetic